if we understand how lactate works and what it represents, we've for sure heard of threshold.
Yeah, definitely. We love talking about thresholds. And I really like this diagram. It's basically what it's showing is that what a good runner has compared to a poor runner is a higher threshold. So they're able to go faster before they hit their threshold. And this is one of the things that we look at with all of our athletes. So in cycling and mountain biking, we're going to call it the FTP. This is something that we look at in Training Peaks, and we're constantly adjusting it through these field tests to make sure that we're setting zones properly, but also testing the athlete's performance. So the reason that we use this kind of a threshold to see how they're tracking is because it's so important for overall performance. Because the higher the threshold is, the longer we can rely on aerobic metabolism and the faster we can go aerobically. So if we can go faster aerobically, that means we can also recover more quickly in between those hard efforts because we have more mitochondria.
The difference between these two plots on the graph, if you have a look, there's the poor runner, which is the dashed one, and then on the right is the good runner. You can see the sharpness of the curve, the slope of the curve. And on the poor runner, not only do they hit the kind of inflection point, that point at which it starts to trend up quite rapidly earlier, so whatever pace that would be, whatever power output that is on the bike, whatever swim speed that is a lot less than the good runner. Other thing is, the good runner has a really shallow curve. So they're going to hit their their threshold later, like at a faster speed. And also when they get there, they're going to be able to exercise at that threshold or slightly above for longer because the rate at which lactate starts to accumulate is a lot slower. So that all comes back to their aerobic fitness. And that's super important in that it's a huge base of aerobic fitness that is going to allow you to develop your threshold. It's not just super above threshold work, but then your training or the training you're applying to your athletes that is going to dictate their ability to shift threshold. It's going to be an important factor, but underlying that, with the aerobic system being dominant after 2 minutes, then that's going to be one of the largest contributors to shifting your threshold.
Yeah, cool. I think one of the things to point out from this graph is it's probably done on a treadmill, and they were doing a VO2 max test. And VO2 max is looking at how much oxygen you're taking in and CO2 you're breathing out, but then you're also taking a blood lactate sample throughout. So taking it at these different speeds or different time periods. So one of the things that we see is when we have an athlete come into the lab and they do a VO2 max test, it feels easy. All these points under threshold feel super easy. Then you hit the threshold, and then your time's limited. You're pretty much almost done because you're hitting the threshold. You're using a lot of anaerobic glycolysis, creating lots of blood lactate, high acidity in the muscle, and your time's super limited because it continues to get harder, actually. So they're almost done after that. It feels really comfortable above that threshold.
Matt, the amount of VO2 max tests were done, and you go, when will I stop? When do I know when to stop?
Yeah.
Oh, you'll know.
Yeah,
Are you sure? And it's so hard to explain, but essentially the treadmill or the power output, just the resistance just keeps going up. What the demands on what you're doing, the intensity keeps increasing. And it's fine. It's so fine. How many more of these steps have I got? Because often it's some kind of step test or ramp test. And so you might have 3 minutes at this output, 3 minutes at a slightly higher. And then it's I don't know if I can do this anymore.
Yeah.
and you stop, right? And that's how we're able to figure out your VO2 max.